a bit more practice of working out exactly what's happening to the graphs just from looking at the functions. Because once you can work that out, you can then go ahead and actually draw the graph of this. So, cos 3x plus pi on 6. Well, the first thing I have to do is write what's inside those brackets in a factorised form. It's cos of 3x plus something. What's the something? Well, if I'm taking out a factor of 3, I'm effectively dividing each term by 3. So pi on 6 becomes pi on 18. So then, my amplitude would be 1. I haven't changed that. My period is going to be 2 pi on 3. 2 pi divided by this number. My horizontal shift will be pi on 18. I'm adding it, so it's going to be to the left. And vertical shift, I don't have a vertical shift. There's no plus something on the end. What are the actual transformations being applied, the geometric description of the transformations? Well, there's no vertical shift or dilation. This period is smaller than 2 pi by a third. So it actually means there's a horizontal dilation by a factor of a third, times 1/3. And there's a horizontal translation to the left of pi on 18. Let's try another one. F of x is negative sine pi x plus 2. So, the amplitude, well, it's 1, but it's inverted. The amplitude is 1, but it's inverted. It's upside down from what it normally is, because that's negative. The period is 2 pi over, what's the number in front of x? It's pi, which means my period is 2. My horizontal shift and my vertical shift are both 0. No, that's not true. I misread it. I forgot about that plus 2 on the end. My horizontal shift is 0, but my vertical shift is 2 upwards. You can just write plus 2. It's a bit more intuitive for the vertical one than it is for horizontal. It's 2 up. So, it's inverted is one of the geometric transformations. Its amplitude is the same size. It's not dilated, but it is inverted. Horizontally, there is a dilation. Horizontal dilation is 1 over pi. It's a little bit narrower by a factor of 1 over pi from the y-axis. The horizontal shift, there isn't one. Vertically, is translated to upwards. One more. F of x is 6 cos half x minus pi on 4. Okay, my amplitude is 6, so it's upright, but it's 6 times as tall. The period is 2 pi over the number in front of x is a half. Well, that's actually 4 pi. So I've got a horizontal dilation. The horizontal shift, is, I have to rewrite this first, 6 cos half x minus something. If If I'm taking out a factor of a half, I'm dividing both of these by a half. If I divide pi on 4 by a half, I'm actually going to get pi on 2. Dividing by a half is the same as timesing by 2. So, my horizontal shift is actually pi on 2 negative, so to the left. No, to the right. I'm not paying enough attention there. To the right. Pi on 2 to the right. Add a positive to shift to the left. Negative shifts to the right. And my vertical shift, there isn't one. There's not a plus something on the end of my function. Okay, let's talk about those dilations. There's a vertical dilation of 6 times. It's 6 times taller than usual. There's a horizontal dilation times 2. It's twice as wide as usual. Dilated again from the y-axis. We translate it to the right by pi on 2. We don't translate it vertically.